In section 1110, we're going to simplify radical equations and solve those equations. And I want to start on page 547. We're going to look at example 2, and that is the square root of 5x plus 1 plus 2 equals 6. When you're solving these, what you want to do is to isolate this part right here on the left side, meaning we need to get this 2 out of the way. So we'll take 2 away from both sides. So our next step is the square root of 5x plus 1 equal to 4. And the reason we want to do that step is now we're going to take the square of both sides. And what taking the square will do is to cancel out the square root symbol. So we can pull that 5x plus 1 out from underneath of it. And then 4 to the second power is 16. And now it's just the fact of solving a simple equation. Move 1 over the other side. 5x equals 15. Divide both sides by 5. And you're going to get an answer of x equals 3. Now, one thing that you want to keep in mind when it comes to your final answer on these is sometimes you're going to be dealing with a plus minus right here. And just watch that as that happens, all right? Let's look at our next example. And I'm going to use the oral exercises on page 548 to do this one. Now the same, my notation was strange here, so you see where I overwrote the square root symbols. The same thing applies. What you're going to do is you're going to take the square of both sides. And I'll show this the first couple of times. Now you're going to have x equals 7 squared, which is 49. And that's as far as you need to go with that. For example 5, same thing again. I'm going to take the square of both sides. So you get 4a equals 100. And now just solve for a. So divide by 4 on both sides. And you get a equals 25. At example 7, the square root of a number equaling a negative. And if you ever see this, just instantly put down no solution. There's nothing you can do to create something times itself to be negative 1. Right? If you made m equal to negative 1, even if you took the square of both sides, here's what's going to happen. This would be the square root of negative 1 times negative 1, which is the square root of 1. So when you take the square root, you're going to get a positive 1, not a negative 1. So you can't have that as a solution. For number 9, square both sides. What you're going to end up with is z squared in this case. Now be careful when it comes to this one. Here's where you're going to have 2 possible answers. Since you have z to the second power equals 36, you're going to take the square root of both sides. And z can be plus or a minus 6 because a negative times a negative equals a positive. Number 10, when you square both sides, you get 3x equals 81. Divide both sides by 3, and you get x equals 27. And number 14. The only way this one's different is that you have a coefficient out here in front of your square root symbol. So when you square both sides, you want to keep that in mind. You're going to square the 2. So 2 times itself is 4. And then the square of the square root of 5b is 5b. And then 6 times 6 is 36. Now remember, you're not subtracting here. This is multiplication. So I would need to divide both sides by 20. 4 times 5 is 20. To isolate my variable. So b equals 36 over 20, which can reduce to, let's see, do both by 4, so it'd be 9 over 5. And no plus minus symbol needed. The only time you're going to need that is when you have an exponent, as we did at number 9 right here, underneath the square root symbol. All right, some problems from the assignment that might throw you off just a little bit. I'm going to do 9, 12, 21, and I think we have a couple more. Yeah, 27 and 33. So just kind of give you an idea how this works. On number 9, again, you want to isolate your square root of b. So I'm going to subtract 2/3 from both sides. So you're left with the square root of b equals, now 1 minus 2/3 will leave you with 1/3. If you're going to do that mathematically, replace the 1 with a 3/3. Now when you square both sides, you're going to get b equals 1/9. Remember that exponent affects your denominator as well as the numerator. All right, number 12. Your first step is, again, going to be to square both sides. So 8 squared is 64, and that will bring your x over 5 out from your radical sign. Now multiply both sides by 5 to get your answer. X equals 64 times 5 gives you 320. And on number 21, this one is kind of like your example 2 we started out with. Subtract 3 from both sides to isolate 5y minus 2 all by itself. So when you square both sides, now you have a solvable equation. 5y minus 2 equals 36. Add 2 to both sides. 5y equals 38. And then to get your answer, divide both sides by 5. So you get y equals 38/5 for that one. All right, next, let's look at number 27. Now, this one is just barely different. You've got to square both sides still. So we'll put that in parentheses. Square that and square that. Now, when you do that, you're going to get 2x plus 9 over 5 equal to 9. So to solve, clear your denominator on the left by multiplying by 5. So you get 2x plus 9 equals 45. It's not done, but I'll let you take it from there to solve that two-step equation. And on 33, to get started, square both sides. Now you've got an a squared under there, so be careful. You've got 2a squared minus 5 equals 11 squared, which is 121. Since you're going to be solving for a, you're going to have a plus-minus situation here with that exponent. So let's add 5 to both sides. So that's 2a squared equals 126. Divide by 2. You get a squared equals 63. Now 63 is not a perfect root. Therefore, we need to break that down into something manageable. Let's see, what can we get out of 63? Remember, you're trying to take out perfect squares, so we're going to take out a 9. 9 times 7. So let's go on up here. You have a squared equals 9 times 7. What you can do is take the square root of both sides at that point, and you're going to get a equals the square root of 9 times 7. And then, of course, the square root of 9 is 3. So a equals positive or negative 3 square root of 7. And I believe that's it. Alright, so on these, just make sure that if you're left with a situation like this, that you don't stop too early. You do still need to break it down. If you have an exponent here, that is going to lead to a positive or negative symbol in your answer. Alright, that's all the examples from section 1110, and that's the end of the chapter 11 exercises you'll be doing. Next we'll move into chapter 12 with the quadratic formula. Now in the section that follows, there is an enrichment, and that's called fractional exponents. It's in an extra section. It starts on page 551, goes to 553. I'll take up to 20 independent study points for doing problems 2 through 40. Make sure you read through those examples. I'm not going to do any online enrichment with that or in class. It's going to be solely for you to independently do. So make sure you turn that in to me if you get that done, or submit it online.